yeah, as I mentioned, my name is Shihu. So I was the former graduate research and teaching assistant in the Civil and Environmental Engineering Department at NJIT. So I'm the incoming assistant professor of construction management at Northern University starting August 2025. So if we look at the first slide, so it basically summarizes what I'm interested in and what areas of research I am doing. Particularly, I mentioned, my research interests include construction automation. This is the main thing, and then I deal with some other things such as robotics, data sensing, and analytics. So it might not very easy to understand construction automation. Let's just use one example. Say, for example, if right now we're doing like an architectural design, a very traditional way is that the owner of the project or would describe how, this project, and give the designer some high-level information, and after that the designer would go back to use some like software tools to do some sketch. It's like a very standard way. If we can automate this process, for example, right now generative AI is very popular. So if we can, let's say, just record some audios from the owner, and then without the designer being there, just get some audio, and then we know audio actually already record what the owners want, the owner wants, and then we can come back, process the audio, and then convert that maybe to some command in order to control the software tool, and then generate some high level like sketch that I would say, because we understand that machine is good, but machine doesn't do work perfectly all the time. So we allow some error. At least it's better than nothing. So instead of doing everything manually from scratch, we have some. For the designer, he or she would have something to start with. You can see in this case, it would significantly speed up the entire process by improving the time efficiency of this project. That's one example. And then my research areas are digitizing build asset management, smart workforce management in construction, and then structural health monitoring and the intelligent infrastructure system. So basically, my research areas span over two fields. One deal with people who are doing the construction. Another one deal with the staff that are made by the people. So, and then so far, I have 12 journal papers plus 2 additional ones under review and 11 conference papers. And then I will start with the first area, smart construction workforce management. Why we talk about this first? We are living in a world, people always mention about one concept. It's called human-centric. Yeah, humans always got to prioritize. So even in construction industry, it's the same thing. So right now, actually, we're facing a workforce shortage issue. This is like an open challenge right now. So given the limited amount of construction workforce, but how can we ensure their safety, their health, and also their work productivity, so that the contractor can deliver the project on time, so on and so forth. So then I'll talk about this project related to workforce management. So we did me and my advisor, and also some high schoolers, we did one project which is called real-time workforce monitoring through robotic teleoperation and mobile multi-modal visual and auditory sensing and analytics. Just to make these things easy. So what this project aims to do is that, so a human operator could be a safety and manager. He or she doesn't have to go to construction sites anymore. So he can just stay inside and then just drive a robot as an agent, which would do the safety or productive monitoring or inspection on his or her behalf. So, and then this project is kind of unique from the traditional way. Now people would say we can just install a camera somewhere on construction site. Yes, it's right. That's what has been researched on for a long time. But they rely on something called stationary sensing, where the camera has a blind spot. And if it's fixed right there, so it can only capture a certain field of view. But for this system, the uniqueness is that we leverage robot as a platform to enable a mobile sensing. So this is the uniqueness. Another thing is this project is something called a multimodality, because the data sources are not only are not only relying on images, videos, but this one also deal with on audios. Yeah. So the slides right here, just show a very high level sketch of this entire system. So as you can see on the left hand side, this is like a remote teleoperator. It's gonna be anywhere, let's say, within like a network, as long as the communication is enabled. So the remote station and the actual robotic agent, they can be far away from each other. And then we go to the right hand side. This like actually this robot we did a study on the unmanned ground vehicle, so still relying on that because the robot there are many types. So then we start with this one, and then this robot is also tracked by GPS. Why? This robot itself is asset of the company. So then we want to know where they are. What if someone take it? Just yeah. Um, I will talk more about what this robot does. Once we move on. So as I mentioned, for this project, we deal with workforce monitoring. So what do we care about workforce, right? First thing is their safety. The second thing is their productivity, right? So these two aspects are focused for this study, but there are many other things we can talk about, like health, or something else. And even for workforce safety, there are different, small fields. Safety from the environment, safety from themselves, right? For example, for this study for safety, what we care about is two things. First one is their safety compliance. You know that when we work on construction site, or even when we do inspection, right, we're gonna wear some protective equipment, hard hat, vest, gloves, and also a facial mask, and so on and so forth. Even especially for the workforce on site, these are necessary. Yeah, especially when they exposed to some hazards like chemicals or so on and so forth, right? They are necessary. Um, it's one aspect. It's the safety regulation compliance. Another aspect is related to their ergonomics, because when they are performing some repetitive tasks, they can do that again and again and again. That may induce some hazards to their body themselves, like their joints, like their bones, and so on and so forth. But given a bunch of emerging technologies, how can we automate this process? Let's say to get some information whether they are in good condition in terms of the ergonomics, or do they really complying with the safety regulation. This can be the things focused by this study in terms of safety. But for productivity, what we do is that because for the ergonomic analysis, what this study does is that it's gonna take a 2D video stream as input, and then going to it's gonna go to do PPE detection, which is a protective personal protective equipment detection. This is one thing. It's like one path. At the same time, there's another a parallel process to do the ergonomic analysis by estimating their skeleton, both 2D skeleton and a 3D skeleton in the image. So this is like a kind of when they do the skeleton estimation, there are two outputs, 2D and 3D. So this 3D one is used to compute an index, something called like a rapid entire body assessment. So through this method to quantify their musculoskeletal risk. Yeah, so yeah, later I'm gonna show more details now, giving some a criteria to say whether they're good or they are at risk or is very severe and so on and so forth. And I mentioned the 3D coordinate, I mean the 3D pose. But 3D pose so far is just used for the safety, the ergonomic analysis, right? Safety rating. This system would also do something called a classification on this extracted 3D pose in order to figure out what this worker is doing. Because as long as we can figure out what the worker is doing, so we can analyze their behaviors over time. And then just say, given a sequence of image frames, we know how many frames the worker are actually doing things. Let's say moving things around, transporting or installing our components. How many frames they are just idling, or they just it just disappeared, right, within the field of view. Maybe they're just somewhere on their phone or anything. But given that, we can roughly estimate their productivity. It might not be very precise. Why? Because sometimes the camera system also has its own issue. So occlusion. What if like there are some other, let's say some equipment on site, block the worker. Actually, the worker is doing the work behind that. So then, so there's like some just pure vision method. So would offer the decision maker some information, but not very accurate. So as I mentioned, the occlusion issue. Why I bring that up? So for this system, we adopted like auditory sensing, because audio, right? There's like the signal can go through some like obstacles. So that's why even with screen, people on the other side of the wall can still hear. So we want to use this to supplement the drawback of the vision-based method to avoid some false false negative. To avoid this, so then that's why this system we designed something called a multimodal, visual and auditory sensing and analytics. We know this system that it's deployed on a teleoperated robot. Yeah, that summarizes basically everything of this work. Yeah, this work right now actually it's under review. I hope this will be published very soon, that in weeks. Yeah, here I can show like one video to demonstrate the PPE detection result, and also the RIBA based, I mentioned, like a rapid entire body assessment for muscular skeleton disorder risk analysis. So actually the result, they are streamed on a web. So the decision maker or the remote operator of the teleoperated robot, and even anyone else who has access to this, I mean actually just IP address, within the communication network, and then they can access like the real-time result. So I can just play this video very quick. You can see on the left-hand side, this shows like the PPE detection result. On the right-hand side, you will see some skeleton, but right now here just to 2D, but in fact, a 3D one was used to calculate those index right there. So, and then the results were, the results are streamed in real time on a web page. So designed by us. Yeah. And then here like shows some hardware setup of this robotic system. So overall are two things: a teleoperation station on the left-hand side, and also like a four-wheel driven robot that carry all the needed sensors, the cameras, and also the mic, and then also as well as like the GPS unit I mentioned, and the brain of this robot, which is a high-performance edge computing device. It's called Jetson HX RAM because this has a very strong computational power. So it's an edge computing device. And then on the left-hand side shows like a regular USB camera that is installed on a Pantio system. Because even when we drive the robot, if the camera is fixed, what if we want to turn the camera to different angles, and then we have to to drive the robot to do that. That may cause some inconvenience. So this Pantio system will allow the teleoperator just to click some button, turn left, just turn the camera, not the robot. Yeah, so to enable more like maneuverability. Yeah, so and then here I recorded one video actually to show how the teleoperation was performed. On the left hand side, so I was driving the robot. On the right hand side, you will see like a web page to show the real-time location of the robot, because we want to track our robot, it's our asset. So at the bottom of the right hand side, you will see when I'm turning left or right, the robot will move left and right. And then once they reach somewhere to capture a good view of the construction site, and then it's gonna start like doing the things I mentioned. It's the PPE detection, the MSD risk analysis, and also to do the productivity analysis, those kind of things. Yeah. So this is a case study we did like at a temple structure installation site. Yeah, let me see if I can move a little bit. I'm gonna switch the end. So the result, it's some part of the result, it's right here. Yeah, that's part of the result. So basically, I show like the result first, and then I'm gonna talk about how we make it happen. Yeah. So, and then here it's just more details about how we can get like the 3D, how we train the machine learning models to do the 3D pose classification in order to understand, what the workers are actually doing on site. So here actually, so we develop a new data set. So we choose the what's that, the timber instruction, the offsite timber is like timber panel, like a assembly site, to get a bunch of like images in order to estimate their 3D poses. After that, we manually label their their actions. So basically, right now for this one, I remember I think there are 4 categories of them. One is called transporting, and the other one is called assembling, and the first one, I think the third one is the measuring and the cutting, because the measure cut, and the fourth one I think it's idling. They didn't do anything. But this is just something we start with. In the future, there are many things to enrich it, to make it more mature, and so on and so forth. And then we get our own data set. So here you can see this skeleton. So we have this in 3D space right there. So here, let me show maybe. Let me just go somewhere. This slide here, you will see for example, this worker right now, it's installing the panel. So then you can see it's knee on the ground. So it's like a 3D pose, those kind of things.
Oh, cool.
Yeah. So we have a lot of them, and then we label them. And for this study, we trained 3 machine learning models. The first one is something called a multi-layer perceptron neural network. This is a very standard one. People call that MLNN. And also we tried the graph convolutional neural network. And the third one is a random forest. So we compare three models to see which one can do the job. By returning the higher prediction accuracy to recognize the workers' actions based on the 3D poses. And then on the right hand side here, you can see it's analysis. It's visualize the results. So there are 4 classes right there. That's those 4 classes I mentioned. So what they're doing, and then the x-axis is the timeline. And then here, each point right here represents what they are doing. So then, for example, the idling here, you will see, okay, for this worker, so there are a few dots, shows that he was idling. But for this worker, if you look at the idling here, you can say it can be more. Of course, when you do the productivity assessment, you will figure it out. But this one is just a ratio to do that. So it's the total amount of frame deducted by the frame, the frames showing the worker idling, and then it's a ratio. So then the remaining over the total, it's going to be the productivity. For example, you can see the first one. Yeah. Oh. And then one more thing, not only idling, another one is disappear. Just gone. Yeah, it's just this two deducted by this two. So the first one actually, he didn't idle too much, but he was out of the view for a very long time. So here the productivity was 67.35. The second one is the truth. Yeah, that's basically I was basically conclude the workforce project, and this part actually shows model architecture to do the construction site monitoring using the audio input in order to to supplement the vision-based method, And then I will jump to the second area dealing with the digitization of built asset management. So for this one, basically I do digitize it. So for my research, basically focus on 2 things. One is the reality capturing, because I want to find something to represent the actual thing built by the people, as I discussed. Another thing is what kind of platform can we use in order to show decision makers or what's going on, which is digital twin. So 2 things. One thing to capture the reality. The other thing is to create digital models in order to show the final results in real time. So yeah, I will jump this part, build assets, buildings, ports, dams, roads, so on and so forth. And then for this, the reality capturing technology are 2 things. One is the 3D mapping system, and then this mapping system is based on a real-time 360-degree imaging system. So it's created by our lab. So here shows some hardware design of the 360-degree camera or imaging system, and then we did some 3D printing. We got the USB camera, from some commercial platform, and then we designed the cover, and also we did assembly together. But for this project, the core is the software. Yeah, but that one is too complex, so I will just show you the final result. Yeah, I just play these two videos right here. So you can see the video on the top is the panorama was captured in the concrete lab in the cotton hole in the basement. And the second one is actually recorded in NGIT quad by the soccer field. You can see they can reach like a very high speed. I remember the frame rate was roughly 9 frames per second. That's like the output. Yeah, so the other thing is like this one has much less distortion, but this system can also produce the panorama in different projections, such as the spherical projection. If that's spherical projection and then you spread out, that's gonna be a lot of distortion in the view. Yeah. So here, like, based on that, you can see somewhere in the middle, this is gonna be one part of the robotic 3D mapping system. Why we care about that? Like, this like a 3D colorist mapping system. We're gonna talk about like when human beings perceive, perceive the environment, we can see the context information and also the 3D geometry. So based on that, or inspired by that, so for this system actually does the same or similar job. So it leverages LiDAR to capture the geometry and use the camera system to get the color context, and then fuse them together in order to generate a digital version of the 3D environment to achieve like the 3D reality capturing. Yeah, I will show you some results so you will get the point. So this is actually like it's part of the hallway on the 3rd floor of Cotton Hall. So you can see there are in total like 8 frames. They were like stitched together through point cloud registration. And you can see it's more like a bigger scale of the 3D scanning, or understand it like a 3D scanning. And then that's for indoor. This is for outdoor scenario to focus on the facade of Cotton Hall, by the main entrance. So it's still like 8 frames stitched together. Yeah. Now you may ask, how can we use it? So if right now we're focused on the facade inspection, like let's say every 2 years, every 4 years. Now you want to find a way to show them, okay, where the problem is, how severe the problem is. This is gonna be the raw inputs. So this is the output of the mapping system, but for your like downstream analytics, so that's gonna be the input for that. Why? You have the images, you have the point cloud. Given that, how can you train some, let's say, AI program to do that for you? And after that, you're gonna come back to mark where that is, how severe, given some, let's say, some standards. Yeah. So that's like I remember once I visited Mott McDonald. They do have this technology. They even told me that they have their own development team to do this job. They showed us a project about inspecting the water tunnel. They built like a 3D, a digital twin of the water tunnel and mark the cracks in the tunnel. Yeah, so that's like I think right now companies are really like adopting this technology so far. Yeah, another thing, the first thing is like RGB cutter. We can only deal with the surface, like let's say defect. But what about the stuff behind the wall or within the wall? So there's another thing like ideas about the thermography. So because thermal imaging can tell us some subsurface like issue. Let's say some like damaged insulation in the wall. But if we just look at the surface of the wall, we cannot identify that. But then the thermal imaging would allow us. So then we know we are developing this system. But part of the result was part of the results have already been published in a conference paper. So basically, what this system leveraged thermal image stitching and the fusion of the stitched image and the LiDAR point cloud together to do the thermal scanning, 3D thermal scanning. That's basically the thing. So here just shows one video about how how 2 individual thermal images are stitched together in real time. So you can see that's actually the blue thing is cup of water, cold iced water, because that of course is much cooler. So 2 views. Why we do this stitching thing? If we only rely on one camera to do that, if we want to like let's say finish a hallway, it's just or a room, we have to work around. But if we can, because the 360 LiDAR can get the 360 view, but this thermal camera cannot, so can we expand the field of view? In this case, we can improve the mapping efficiency. We don't have to like do this, let's say to scan back and forth. maybe one time you scan over, then move to the next place. Yeah, that's like the uniqueness of this system. And then here shows more details about how the thermal image and the point cloud are fused together. So here just shows one frame of it, just like, but this work is still ongoing. And then this is like a digital twin thing I mentioned before last time. It's like, we leverage like a beam robotics and also internal things, those kind of things. But this project is for indoor environment monitoring. But this also focus more on the occupants, their health. Yeah. And then another one is for structural health monitoring, particularly like focusing on monitoring the structural behaviors like deformation, deflection, and so on and so forth when a load is applied on like any component of the structure. But this is just a prototype, so in the future we're considering to scale up this project, and also to try to test this technology maybe like in a real project. So the third one is going to be intelligent infrastructure system. So my work mainly focus on bridges and the pavement, but I'll talk about pavement more because it's a recent work. Even like our last talk, I didn't talk about this because our work was ongoing. So for this project, particularly robotics got involved, teleoperation actually, and also the AI thing also. But for this one, the AI is a bit different from what we have done before. So we particularly improved a state-of-the-art deep learning model called You Only Look Once version 9. So which was state-of-the-art last year. It's very strong for object detection, giving visual data. Yeah. But what we did was we introduced something called efficient multi-scale attention. In order to enable the original network to better capture, let's say, the features of the object you are interested in. For this project, we choose pavement pothole because the pavement pothole, you can see when we drive every day, right? When you see pothole, the first reaction is yo, turn left, turn right.